Hey, hello everyone. We're back with another video here with Svix. Tom, how you doing?
I'm good. How about yourself?
I'm doing great. So today I wanted to ask you about how Svix has switched a lot of our code base over from Python to Rust. So it's something that I hear you and the other developers talk about a lot, but it's a little bit over my head. So I just had some questions. So the first thing that I wanted to know is what kind of got you started with Python?
Yeah. So I guess when we built Svix initially, it wasn't even called Svix back then. The important thing was to get something off the ground, something that we can actually, get ready for customers and actually have them try. And I knew, I wrote all of the code in the beginning. I knew Python best. I had code samples locally that I've, deployed to production. So I'm just like, okay, building Svix in Python is a no-brainer. It's going to be very quick and I know how to do it. And also Rust. I was a big Rust guy back then as well, but Rust definitely wasn't web yet. It was before
so
we
you,
really
so you
casting.
were already familiar with it.
Oh yeah, I wrote actually a lot of production code with Rust before we started building Svix, but it wasn't web yet. And also, even though I did a lot of Rust, I wasn't sure we're going to be able to find a lot of developers that want to do Rust rather than Python. Python developers are everywhere. Rust are a bit more rare. So that's kind of was the thinking in the beginning of why Python was started. Although calling it thinking is maybe a bit of a stretch. It was really just okay, we need to do it. Let's just do it. We weren't really evaluating anything back then.
Mm-hmm. So when did you start? After you launched, did you start thinking about switching? Was that in your head from the beginning that you might need to do this?
Yeah, I think it was, again, the same way it wasn't really thought out. The choice of Python wasn't really thought out. It was also the choice of sticking with Python wasn't something that we thought about a lot. But we started getting a lot of, first of all, performance issues. Not performance issues, but performance limitations, and that really just weren't fun. So definitely, a few people mentioned Go over the years, and Rust was also brought up, and we were thinking about it, but not actively. We had, we were using typed Python and Fast API and SQL Alchemy, all are great libraries, so we were really happy with them. But yeah, there was in the back of our heads, there was a little demon or a little maybe angel whispering that we should consider switching.
Hmm. So then what was it that made you decide, okay, we're going to actually do it, we're going to switch?
Yeah, there are a few things. Quite a few reasons, actually. One thing was definitely the performance thing was starting to get annoying. We also, having a single binary and smaller containers were a plus as well. We're using AWS and ECS, and we're using Lambda for a few things, and just having the massive, all of the depths and packaging them and having all of that was just really not a lot of fun. Of other reasons, I guess also. As I said, we used typed Python, which was good, but it still wasn't great. The type system wasn't very expressive, and you could still get type mistakes. Even though we actually have a lot of, we've had a lot of additions to our code base to make typing even more strict in our Python code base, but still it just wasn't the same. I guess those were probably the main reasons.
So when you say having this single binary, can you explain that a little bit more? Because I'm not as familiar with how the binary files and stuff works. Why is it good to have one? Why can't Python just do one? I guess are the two questions that popped in my head.
Yeah, it was. So Python is a scripting language. So it actually, you just pull. So when you install a library, you really just install a script, put a script somewhere in the file system, and then the Python interpreter just loads it. Again, going very deep, but essentially you have when you have a Python deployment, you have a lot of files that need to be in a specific place in the file system. And it was just really annoying to make sure, obviously we solved it, so it wasn't annoying at that point, but it was really annoying to make sure that everything is in the right place, both for Lambda and ECS. But also another thing is because, Python kind of assumes you have a full system in place and have all of these things, you actually end up having very large containers, while Rust ends up being a very small one single file. So
gotcha.
Again, it's not we shouldn't stay on this point for too much because it wasn't the main driver. But just having smaller containers means like faster, like startup time, and all of those kind of things.
Okay. So like once you decided like you needed to switch off of Python, right? Then you were mentioning you had a few options, right? So you had mentioned Go specifically. Were there any other options? And then like why did you at the end up with Rust?
Yeah, so there are like a few popular options, I guess. We could have chosen Kotlin, maybe Elixir as well, you could say. But at the end of the day, I was the big Rust champion in the team. There was another guy that was the big Go champion, and I think between them, those are the languages that we had like the most excitement around, and also we were most familiar with. I mean, I wrote a lot of Kotlin code in my past, but not Webby. So I think, those are probably like the best options for us because of that. And also, again, the single binary thing also makes it easier for people to just like run it locally, like without having to set a Java environment and all of those kind of things. So yeah, that's kind of like why we're thinking between the two of them. So Go and Rust.
Mm-hmm. And you just ended up picking Rust because that's what you wanted.
Not really. I mean, yes, but no. Essentially, what we did, we had the Go champion implement a few routes of our API in Go, and I implemented a few routes of our API in Rust, and we kind of like looked at both of them, and the Rust code was much cleaner. First of all, I mean, I gotta admit, like full disclosure, not a Go fan.
Okay.
No, the lack of generics back then was like terrible. The weaker type system, the fact that there's a null, which is considered, I think, like the $1 billion mistake. I don't understand like why they have null. The implicit imports I don't like. I don't like the uppercase for naming for visibility, error handling. I mean, I really like potentially also the garbage collection, but like everything else is such a killer anyway before. So I didn't even like get, but that's probably like also an issue. But anyway, I was very biased, as you can tell. But essentially, we looked at the code that was generated, and Serde, or whatever you pronounce it, with like Rust, actually made it much nicer than like what we had in Go.
Gotcha.
So yeah, we ended up choosing Rust.
Okay. But I know like you had mentioned earlier also like you did have some concerns with Rust, right? It wasn't just like everything is all rosy over there.
Yeah, we like taking bets, but careful bets, right? At the end of the day, like stability is something that we care about a lot, and developer speed, and I mean performance in general, to be honest, but also the speed of development. So like all of those things are things that we really value, but we're willing to take a bet if it feels like a safe bet. And I think Rust has been web ready, I think, for a while, a few months maybe. But when we like wanted to switch, I don't even remember. There was like Actix, there was Rocket, there were like a few of those kind of things. So I think we felt it was fine. We definitely were concerned about, the smaller pool of developers. Like there are just so many Python developers, not as many Rust developers. But I think we actually were proven wrong in a way because, first of all, the average quality of like a Rust developer ended up being higher than a Python developer.
Yeah,
I mean,
makes sense.
I'm also a Python developer, so I'm not dissing Python developers. It's just in general when you have like, as an esoteric language, the people that are more geeky about those kind of things tend to go there. And yeah, I mean, the other thing was, development speed, which was a concern, is a concern, I guess. Like compilation time is slower. It's really annoying to have like to wait for us to for the project to recompile. But also, it's actually not that slow. And, it's really nice. It just it's so much nicer though that when you write code, that because of the type system, everything is going to be safe and everything is going to be fine. And we you end up, so development itself is like a bit slower, but actually you end up spending much less time debugging stuff, both locally and, in the staging environment. So it's kind of like almost faster in a way. Does that make sense?
It's like the initial build is slow, but you don't have to build it multiple times.
No, it's not just that. It's like kind of like the initial, while you develop, like, I think I found an issue. You change, you have to wait like 5 seconds until like it runs again, which is annoying. But also you don't have to go and like find a bug that is causing by the type system, like that would have been caught by the type system, and then like spend 5 days like figuring out like what went wrong, if that makes sense.
Okay, yeah, that makes sense.
Yeah.
All right, so then like once you decided, okay, yes, we're going with Rust. So like, what was it like actually like making that change, like making the full switch from Python over to Rust?
Yeah, so we had the Rust. Yeah, I mean, we so essentially what we did. I don't know if we could have done it better. Like it's always hard thinking about like in retrospect. But essentially, we went so both cluster of endpoints at a time and one endpoint at a time within. And what do I mean by that? So we have like an application entity. So we decided, okay, let's first switch applications, and within applications, let's first switch the get and the list. And the way we did that, we had like a load balancer that just would, just direct those, those API calls to Python and the new API calls to Rust, like the ones that we've converted, and kind of like go step by step there.
Okay.
This is very hard and dangerous, I guess, to have like full compatibility, including like bug compatibility and all of those kind of like different places. But we had a very robust, we still have it, like a very robust end-to-end test suite. And just like running it on Rust helped us go, help us like have like very high assurance that what we did is correct.
Okay, so you like chunked it out. You didn't like stop everything, try and code the entire thing in Rust, and then like switch. It was like a slow, like one by one.
One by one, and
migration
also kind of like sometimes, like have... like not go the whole 100% of the traffic, just go part of it. Like really just playing with the load balancer, like making sure it's correct. Obviously testing it in staging for like months before making a switch.
Right.
That was like an important thing. Another thing that we did actually was a bit of a hack where we got like a few customers that wanted something specific implemented for them, and we're just like, hey, we can deploy this like new like backend for you. Just so you know, it's like beta, but like, and they were actually running it for a while before. So we also had like this like real almost production level of like data and like usage before we even like tried switching over staging and prod.
Oh, okay.
Yeah.
So like not only just like one component at a time, but like at some level, like almost one customer at a time.
Yeah, it definitely was one component at a time, but we also had in parallel like one customer that actually got the like special treatment. And obviously ourselves, like we ran it again in local and in dev and in local development environment and staging environment way before it ever hit production. Look, it was a bit annoying, or maybe even very annoying, but we're actually happy. I'm very happy with what we got.
So like what were the results? So obviously at the beginning you said, the main reason for switching was like the performance. Like what are the performance improvements that we've seen?
Yeah, so latency is down. That could also be attributed to some other changes that we did at the same time, but like we definitely noticed lower latency. Many less API workers. Because I think, I don't remember the exact benchmarks, but I think it was like 20x or 40x faster, like Rust. So I think, just think about it, like 20x less workers, 40x less workers, whatever. So that's like a big difference. Yeah.
Is the less workers like more an impact on like our end with like just like cost from a cost perspective, or does that also impact like the user experience?
It's mostly cost, but it also kind of, it gives you benefits from like being able to cache stuff in memory rather than like in a distributed cache store. So it's kind of like also performance as well. So it's kind of like, I can't have like I don't have a comparison in mind, but essentially it's kind of like, okay, there's 20x, but also you can also do all of these things now that you weren't able to do before that kind of like make things even better.
So it's like 20x improvement on certain number of things, but then it's like a 0 to 1 improvement on these other things where it was just like not possible before.
Exactly. Let me give you an example. We've used Lambda in some places before, and Lambda. I'm actually not a huge fan, but like that Lambda is okay. But the problem is, with the time it takes to like start, and the lack of like in memory caching and all of those kind of things, that for these things we were now able to use just like a Rust worker that just is just there. Again, that we get all of these benefits as well.
Okay. Well, that was actually very important. A lot of that stuff I didn't understand, right, from before. So it was good to get like more background on it. So I was, I think the last thing that I was just wondering is, like, do you have any tips for other people who are thinking about this, like who are on Python right now? They're kind of feeling that's the same pains that you were feeling, like.
Yeah, I mean, actually, even before the tips, I can just share like some of the things that we didn't realize that we're gonna get, and we did get. Mm-hmm. Like one of those we touched upon, which is like the development speed. It's actually, in a sense, much better. We definitely have like higher trust in our code. It's kind of like, okay, does this compile? Yeah. Okay, I guess like it must work. Like, all of the constraints kind of like make it into place, which is, it's kind of like fun. And and we see it like every now and then. We still have like some not microservices, like some components that are like and microservices as well, like that are in Python, and we see that like when people make changes to them, they're almost like a bit sloppier than they used to be, because they're used to like Rust just telling them like, hey, with the type system, like, hey, this is probably correct. I don't know, like I was really pleasantly surprised by like how much more we trust the code base and our changes and again the development speed. So like one advice, and it's kind of like something I touched upon, is we encode everything we can in the type system. I'm not just talking about like putting an int as an int and a string as a string, because that's obvious. I actually mean, like different strings are different strings. So an email and a password are both strings, but they're not actually interoperable. Like you wouldn't put, a password in an email string or vice versa. Or like an identifier for an application and identifier for a message are not the same. So like you shouldn't be using one and the other. And we just really have strong enforcements for these types, everywhere we use them. Which just means we can never pass the wrong thing. Like, sometimes you have like it's just like everything is caught by Rust. And we also have, like other things, like we have a cache backend. So when you put a specific cache key, that is actually typed, and the type is connected with the type of the value. So I know it's confusing, but I'll get to it. So like if you want to like cache an object, like if you want to cache an application, you're going to pass like an application caching key, and you only be able to pass an application to set that into the cache, and only be able to read an application from the cache. So that means that even though, Redis, for example, which we use, is not really typed, every access that we have is actually typed. So what I'm trying to say is that we can never, or very rarely, can get things wrong that are not caught by the compiler. And I think that is like my number one tip. Sorry. Another thing that I know some Rust people may not agree with, but one of the main complaints people have about Rust is kind of like, the borrow checker, or like, hey, the compiler is too aggressive, too hard, like, all of those kind of things. And I think, one solution is obviously like getting better at Rust and kind of like figuring out like how to encode all of these lifetimes and all of those kind of things everywhere you want it. But another approach is just to kind of like learn to let go and not worry too much about fighting the compiler. So like, sometimes you can like figure out the lifetime, but also maybe just a clone. And if it's like a small enough copy, like we said username earlier, so if you just like clone the username, not optimal, but the grand scheme of things, we do like JSON serialization, we go over the network, we do have database access, all of those kind of things. Optimizing this is not gonna move the needle for us at all. And if it makes the life of developers much easier, we just like, let go. It doesn't mean that we don't borrow. We actually borrow, and we use like Rust lifetimes, and we do like the smart things and the right things like wherever we can. But we also kind of like learn to let go when it's things that really just don't matter.
Okay. I mean, that's really interesting to me because, for me, obviously, when I'm hearing you guys talk about it, I hear performance. That makes sense in my head, obviously, right? But a lot of the benefits that you're talking about, the tips that you're giving are more about like the actual development experience inside of Rust.
Yeah, I mean, I think the thing is about Rust is kind of like the moment you went Rust, you're already like 20x or 40x of performance just by existing. So if you have to pay like a 1%, 2% penalty to just have, like a better developer experience, that's probably worth it.
Yeah.
And that's kind of like, that's the lesson. Like just using Rust, you're probably going to be faster. You can be slower. It's not magic, but you're probably going to be faster. So those things are the things that matter.
All right. Do you have any other thoughts on the switch that we made, or?
Yeah, we love Rust. I mean, really do love Rust. I hope more people use Rust. I guess we use Axum as our API provider, API framework. We really love it as well. We used Hyper and all of the Tokyo ecosystem. There are like a lot of good, libraries out there in the Rust ecosystem. Yeah, man. I think that's it.
All right. Well, Tom, thanks again. I always love doing this. I just learn a lot. And I get I get a lot of context that I didn't have before on some of this stuff. Where, I hear you and the other devs talking about stuff, and it's just like, we get to talk about it. Now I understand it a little bit better.
Yeah, and if you ask me to geek about like some of our tech or Rust in general, like I would be more than happy to. So we can do many more of these, as many as you want.
All right. Yes. All right. So again, if anybody watching has any questions for us about the Switch or about anything else, just leave them in the comments, and we'll get back to you, and we'll try and address any questions you might have. Thank you. Thanks, Tom.
Thank you.